Hi everyone. Today we're going to talk about angle relationships. In the last set of notes, we learned how to classify different angles as acute, obtuse, or right, and how to measure angles. This time we're going to talk about how angles relate to one another. So let's start with congruent angles. Angles that have the same measure are congruent. That's just like segments that have the same measure are congruent. If they're the same length, they're congruent. With angles, we talk about angle measure. Congruent angles can be matched with matching number of arcs. So right here, we've got these little things here. Those are arcs. And if you have the same number of arcs on each one, then those are going to be, so we have one arc on the left hand angle and we have one on the right. That means that those are congruent angles. And we could write a congruency statement from that and say that angle ABC is congruent to angle DEF. Okay. And remember, when we name angles, the vertex is always in the middle. So B is our vertex, E is our vertex. If two angles are congruent and represented algebraically, then we're going to set their measures equal to each other and solve. So if we have two congruent angles, this is going to be a situation where we have angle equals angle, or part equals part. It's going to be very similar to when we had congruent segments. Same idea. So in other words, if we have congruent segments, we're going to set their measures equal. So the measure of angle ABC equals the measure of angle DEF. So we've got to try this. Let's try this next one. We've got if angle ABC is congruent to angle FED. First of all, let's label that. So we're going to put one arc on each one. We need to find X and the measure of ABC. Let's go ahead and highlight what we're going to find there so that we don't forget. All right. So we have two things that we're looking to find. So we need to set this up. And again, this is going to be, since these two angles are congruent, we can set them equal to one another. So the measure of angle ABC equals the measure of angle DEF. And the measure of angle ABC, it shows us right here in the middle, the measure of angle ABC is 4x minus 3. The measure of angle DEF is 6x minus 23. So we can set that up and we can solve. So first thing that we're going to do is let's get all of the x's on one side of our equation, all of the constants on the other side. So I'm going to start by moving the x's all to the left by subtracting 6x from each side. The next thing, when we do that, we get negative 2x minus 3 equals negative 23. So all of our x's are on one side. Now I'm going to move this minus 3 to the right by adding 3 to each side. And we get negative 2x equals negative 20. Divide by negative 2. And we get x equals 10. But we're not quite done. So that was finding x equals 10. The other thing that the question asked us for was to find the measure of angle ABC. So what we need to do is take that x equals 10 and plug it back in. So measure of angle ABC is going to be equal to 4, and then instead of writing x, we're going to substitute 10 minus 3. That gives us 40 minus 3, which is 37, and we want to label this as 37 degrees. So that's the measure of angle ABC. And we're done. Okay, so that's congruent angles. The next type of angle relationship we're going to talk about are adjacent angles. So adjacent means next to each other. If you live adjacent to someone, that means you're their next door neighbor. So adjacent angles are a pair of angles, and they have to have three qualifications to be adjacent. First, they have to share a common vertex. So the vertex, remember, is that point where the endpoints of the rays meet that form the angle. So that right here, this x, that's our common endpoint. And they need to share a common side. So this ray in the middle here is their common side. And finally, they do not share interior points. So interior points are points that are on the inside of the angle. So notice that the red and the blue don't overlap anywhere. There are no shared interior points. Okay, let's go ahead and look at the next portion here. So let me move my... Okay, so the next thing we're going to look at, if you open this up on the left-hand side, we've got the angle addition postulate. So we've already had the segment addition postulate, where we had part plus part equals whole for segments. It's going to be the same thing here, except it's going to be part plus part equals whole for angles. So the angle addition postulate allows you to add the measure of two angles or more, you could have more than two, together to solve for the measure of a larger angle. That's the whole. Or you could solve for the measure of one of the smaller angles, the part. And here we go. So this is the formal definition here. The angle addition postulate states, and they're using this diagram here, if R is in the interior of PQS, so angle PQS, then the measure of angle PQR it's not a Q. So when they're talking about PQR, that's this angle right here, plus the measure of angle RQS. That's this one over here. I'm going to put two arcs because we don't know that they're the same necessarily. So add those together and you get the measure of angle PQS. And again, just like before, that's telling us that one part of this bigger angle plus the other part equals the whole. Okay, part plus part equals whole. Next thing that we're going to have are angle bisectors. So once again, we had segment bisectors. Angle bisectors work very much the same. If a line, a segment, or a ray cuts an angle and a half, then the two parts of the angle are congruent. So an angle bisector is just a ray, excuse me, or a segment or a line that cuts an angle into two equal parts. And you'll notice that we have in this diagram on the left, they show that by putting one arc in each angle. So those angles are congruent. So we can write that. If BC is an angle bisector of angle ABD, then angle ABC, it's the angle on the left, is congruent to angle CBD, or the measure of angle ABC equals the measure of angle CBD. And that, again, this case, this is going to be part equals part. So let me write that in a different color for you. So these two parts are equal, so they're congruent, so we can set them equal to one another. This is going to be part equals part. All right. Let's go onto the top right, and we've got 4 examples for you to try. Let's go, let's try them together here. So number 1 says, find the measure of angle 1 if the measure of angle ARC equals 67 degrees. So first of all, we have to see what they mean by ARC. ARC looks like that's the whole. Okay, so let's go through and mark up. Measure of angle 1 is what we're trying to find. The measure of angle ARC, we look ARC, that's our whole. And we have our 2 parts that we can mark on the diagram. Here's one part, that's angle 1. Here's the other part, which is 32 degrees. So we're going to use the angle addition postulate, which says part plus part equals the whole, and we're going to fill all those things in. So the measure of angle 1 plus the measure of angle ERC, which is 32 degrees, because they give that in our diagram, equals the whole, which is ARC, measure of ARC, which they give us as 67 degrees. And now all we have to do, we're solving for a measure of angle 1. So in order to get that alone, we're going to subtract 32 degrees from each side of this equation. And that leaves us with the measure of angle 1 equals 35 degrees. Okay, the next one is going to be set up very, very similarly. It looks like here it says to find x and find the measure of xyw. So that's actually one of the pieces, one of the parts that we're going to have to find the whole. And it tells us if the measure of xyz equals 142 degrees. So let's mark this up as part whole. So first part is going to be for x. The other part is going to be 10x plus 16. And our whole, the xyz, they give it to us at the top. That's 142 degrees. So we get part plus part equals whole. So go ahead right now and see if you can set up that equation, filling in the part, and the whole. Okay, so this is what your equation should have looked like when you set it up. You should have gotten 4x, because that's the first part, so that's this part, plus 10x, and that was 10x plus 16, which is this part, and your whole should be 142 degrees. So that's that part. So go ahead and solve that equation and put in your answer. Okay, if you solve that correctly, you should have gotten x equals 9 and the measure of angle XYZ equals 36 degrees. Let's look at these last two, and I'm going to help you set them up, and then you're going to do the solving. For this number 3, it tells us that we're going to find x and the measure of angle LMO if MN is an angle bisector. So remember, angle bisector means those two angles have equal measure. So is this going to be a part plus part equals whole, or a part equals part? That would be a part equals part. All right, go ahead and set up those equations. Okay, you should have set it up like this. The first part, x plus 2 equals 23 minus 2x. So go ahead and pause the video and solve this. Okay, so if you solve that correctly, you should have gotten x equals 7, and the measure of LMO, which was the whole thing here, is 18 degrees. And I did that by finding one of the parts and multiplying it by 2. Since it's a bisector, they're equal, and we can do that. Number 4, they tell us, they give us a congruency statement. Angle NKL is congruent to JKM. So go ahead and set that up. and see if you get it right. Here's the setup. Now solve. There it is.